Okay, this is the second recording of question two. As so in question two, we are considering an interesting question. Y is salary, your income, PhD is income, and X is your econometrics knowledge. I'm curious what is beta, right? But econometrics knowledge is not directly observable, but I only have econometrics test score. Midterm score, final score, and how do we do this? Okay, second one. I am writing equations like this. This is fundamental equations, by the way. These are the structural equations. These three equations define how those variables are generated. But this equation is not does not have any structural meaning. We just this equation means we are going to regress y on m. That's all. I don't know what is beta and what is alpha, and the relationship between y and m are defined by these equations, not this one. So you have to distinguish them. You have to understand the differences. And in the previous and assumptions here. So in here, I want you to realize this. So three equations. Three endogenous variables are generated from four underlying variables, right? X, epsilon, U, W. These are four underlying variables that generate three endogenous variables. So it's like simultaneous equations model, okay? And my assumption, I will use these assumptions. See, all the observations are mean zero, error terms are mean zero, and covariances are zero, right? So especially those four underlying variables, any pair of these four variables has zero covariance. That is these assumptions, right? There are six covariances, right? 1, 2, 3, 4, 5, 6. Six covariances are all zero, and error term is also zero. And in the previous recording, I showed you a very useful technique, right? So let's see. This is so like think about three equations. We number them. Suppose that we number equations because we want to mention those equations in a later part, right? So I define equations here, but we have to mention them somewhere later, right? But the problem is later when you edit your dissertation and your paper, you add new equations like something like this, and you want to number this one too, and then this numbering is different from these numberings. Like I wanted to refer to the first two equations, which used to be 1 and 2, but now it is 2 and 3. So matching the numbers is really annoying job. And if you delete this, then it gets correct. But you know what I'm saying. So if you edit, as you edit, the numbers are automatically changing. So you have to match that. A simpler way to do that is using equation label, right? So you may right click and put equation label here or insert label here. I will call this salary equation. The name of this equation is salary. And I will or you may just right click equation label. I will call this midterm equation. They are now the names of these equations. So when I mention the first equation here, instead of just using the number, I can use their name. Put insert and cross-reference. And then you just choose salary. And cross-reference midterm. And then if you compile, like click this view, if you compile, let's see, is it compiling well? So then number 2, number 3 is mentioned here correctly. So uh, this will save a lot of time. Like of course, if you even if you delete that, automatically these two numbers will be adjusted according to these names. Okay, anyhow, that's a important technology to save your time and to save your mistakes, right? Uh, and even if you use LaTeX, the names are the same. The label and cross-reference. Label and cross-reference is what you have to search for when you try to use this. Anyhow, again, back to the content. You have to tell what is generated variables and what are underlying variables. Okay, so then like from the first and the second variable, like equations, I will replace x with m. But so to replace x with m, it's simple. Just add and subtract u, right? So or you can like move u to the other side. But I just want to keep the equality keep going. So this will be more intuitive writing. Okay, as a result, I have a new error term, epsilon tilde, which is this much. What is interesting here is, in this setup, beta 0 is beta tilde, but the problem is uh, endogeneity, right? This is one possible approach. Or if you define tilde beta as, it is possible that you may define it this way. Then this is different from beta 0, but there is no endogeneity problem. So it is up to you. You may use this technique, or you may define it this way. But but also this is an example where I was not clearly stating the question. I should have fixed which way you have to take. But like yes, it's confusing. Like, so the difference here is, if you take this approach, there is no beta tilde is okay, but endogeneity is the problem that causes the bias. If you take this approach, you don't need actually, the problem is the bias in beta tilde using m instead of x, right? So in this case, endogeneity is not well defined. So I leave the question unclear. I'm sorry about that, but I will take the first approach. I will take this approach, not this one, right? Still, like both are correct, but for consistency, I'm going to maintain this approach. And then if you take this, and if you like from the regression of y on m, we would like to the bias is this difference. Okay, the difference is like this, and we calculate from using equations 1 and 2 again, using equations salary and b term, we obtain the covariance can be written in this way, right? Then you will get this. So the bias is, you will like replace m like y with like this epsilon tilde, and then you are going to get these things. You like get this. So the bias is this minus beta 0 is like this. So up to this point, it is not wrong, but what I recommend is replace those covariances. Like I mentioned, m is not underlying variable. Like m is endogenous variable from the system of equations. So I recommend you replace m with this form, right? And epsilon tilde is over, of course, it's just a temporary notation. Epsilon tilde is from here, it does not exist. It does not exist in our model at all. So epsilon tilde is just a notation, right? So I recommend you change those epsilon tilde and m into the underlying variables x and u, right? So that is not a big problem. Or you can do this as like as so covariance y and m will be calculated directly from equation 1. Yeah, this is better approach. So yeah, so this is the what I could do because I'm recording it twice, right? So you can directly find out what you get, and variance of m is like this. So you are going to get to the same result. Oh, minus. Where did this minus come from? Ah, oh yes. So then the bias is so if you calculate that, I think you will get something like this. Or did I do any better? I'm not certain. I think I did well. Anyhow, so like if you come, please let me know. Ah, this is not x. This is u. Sorry about this. Yes, it is correct. So typo. I fixed another typo from the previous recording. So this is the bias, and this is the same thing. If you calculate that, you will get the same thing. It's up to you. And again, the main point is both are correct, but the main point is you are going to replace endogenous variables with underlying structural expressions, right? Express endogenous variables using underlying structures, okay? And then now we realize that there is a bias. You may think that that's because of this endogeneity. So we have to think about instrument, which is final exam score, and you have done pretty well. It is easy to show this, so I will skip these. And from these two assumptions, I thought it would be really easy to prove the identification, but many of you are not doing a good job. So let me show you the moment condition approach. The moment condition approach is based on these two moments because we have basically two parameters, alpha and beta. You need two moment conditions, which are coming from these two. Uh, like it is the second one is actually not necessary. Without the second one, still you can identify beta. Alpha is not identified without the second one, but beta is identified without the second one, but it will be easier to have it here because by the second assumption, you can replace covariance with expectation, right? So covariance can be written in this way, but this is 0. So you are going to get simple expectation. For example, you may do like this, right? Cool. Anyhow, so you can replace covariance with expectation. Then from there, it's a familiar algebra. it's a 2 by 1 zero vector equals like that. That's basically epsilon tilde, and we are based on this equation, okay, because we are handling the endogeneity problem in this equation. Then you can write this system of equations as two linear equations. So you get this, and as you know, it's a matter of invertibility of this matrix. If this matrix is invertible, then you are good. And determinant is not zero. For this to be invertible, the determinant should be non-zero, and the determinant is this guy, which is covariance, and it should not be zero, right? So covariance, non-zero covariance is the relevance condition we proved earlier, right? That's it. So if you show that covariance, when covariance is not zero, this matrix is invertible, then that is the proof, identification proof, okay? If you use the fitted value approach, some of you have used fitted value approach, but the answers were not complete, right? So again, the second stage equation is exactly what we set up earlier. And you have to add an equation, new equation for M. Now regress M on F. This is a reduced form equation. Delta has no meaning. This is a reduced form equation, and here covariance, like for this new equation, new error term, I'm going to impose these things. The second one is exogeneity assumption, but the first one is it is by construction, right? When you linearly project M on F, you're going to have zero here. So anyhow, like you set up the second equation and plug in the second equation into the first one. Then you have to split this part and the other part. This is psi is correlated with the error term, so split them. And psi is observed into the error term, and the other part, the fitted value is replaced by M hat, right? As usual. Now what you have to do is, this is not the end of the proof. You have to show that this is a new regression model, Y on M hat. So you have to show that M hat satisfies the exogeneity and the full rank assumptions. Then those coefficients are identified. So like it has been many years I've been using similar questions like this. Surprisingly, a lot of students are using fitted value approach in their proof. But that is more difficult because you have to go through many steps. First, you have to show this first correctly. You have to show this correctly first, and then you have to define this. Usually it is not a problem, but from there, you have to plug that back into there, and you need to prove identification of this guy, right? So, as I mentioned several times, fitted value approach is only for computational convenience. That is huge, right? That is important. But for proof, I don't think that's a good idea, right? So almost always, moment condition approach is simpler. It is because you know how to solve linear algebra using matrix, right? That is much easier. Then this kind of several step analysis, you can easily make a mistake somewhere, and then all the following steps could be wrong. Oh, okay, I recorded a lot today, so I hope this helps, and I will finish grading later and record more reviews on question 3. Thanks, bye.